Okay, hey, we're going to do a little more work on the arithmetic and geometric sequences and series. I want you guys to be able to figure out recursive and what we call explicit formulas. I want to focus a little more time on this. So today and tomorrow we're going to work on a little bit more on this and then move on to our next subject. Okay, recursive and explicit formulas. This will be your worksheet for tomorrow. Remember, we have some sequence or series where we have A1, A2, A3, all the way up to AN. A recursive formula is a formula for each term of a sequence that it depends on the previous term. In other words, to determine A12, A sub 12, the 12th term, you must know A sub 11. Okay, so let's consider this. Here's A1, and we did a little of this. A2 equals 3 plus 4 equals 7. Okay, and here's A3 equals 7 plus 4. Notice we took equals 7 plus 4 equals 11. So we notice that basically my nth term equals n minus 1, which is what? The previous term plus 4. Okay, notice. But we needed what? We needed the first term to define something. So that's a recursive formula where we need preceding terms to help determine the formula. Okay, so here's a formula, works really well, but guess what? We can't figure out A sub n without the previous term, okay? Explicit formula is what we're used to for like normal functions. For linear and quadratic equations, you plug in x and you get out y. For a sequence, again, A1, A sub 2, A sub 3, all the way to A sub n, an explicit formula is a formula that allows direct computation of any term of the sequence, okay? So here's an example that this formula here in recursive we said was a to the n minus 1 plus 4. But now I'll show you how we get this 4n minus 1. So here we can just plug in 1, 2, 3. We don't need the preceding term. It's an explicit formula. We plug in 1, we get the nth term, 2. Okay, so we'll graph. Notice this graph here. And we did a little of this in geometry and algebra 1, determining a formula from a table of data. But here's n, which is the first term, second, third, etc. And here's your output, your nth term. You plug in 1, you get A sub n. Plug in 1, you get the first term. You plug in 2, the second term. 3, third term, and so on. Okay? First thing we look for, and this is we'll figure out how we get this, but it's just figuring out in this case, let's take a look if it's linear or if it's a linear equation, we know it's arithmetic, and if it's not arithmetic, we'll look to see if it's geometric, okay? I look at my difference of my outputs of my terms. The first term, second term is 4 plus 4. 7, 11 plus 4. 11, 15 plus 4, okay? So I know I have a constant rate of change of 4n, okay? So that's basically my slope. This is like 4 times n, okay? So I can take any one of these, 3, 11, any one of these pairs of input-outputs. Fourth term, n is 4, the fourth term is 15. N is 3, the third term, and so on. It's basically x and y. All right? So let's just do 3 and 11. If I plug in a 3 here, 4 times 3, I'm going to get an output of 11. Okay? Remember, y equals mx plus b. Okay, so basically this right here equals 11 equals 12 plus or minus some b. Okay, so what do I have to do to go from 12 to 11? Well, let's just go ahead and minus 12. Of course, 12 minus 1 will be 11, but we'll do our algebra. 12 minus 12 is 0, and 11 minus 12 is negative 1, and that's our y-intercept of b. But we've got our equation of my output, a sub n equals, or y equals 4n minus 1, okay? And that would work for anything. Again, I look at my input of, let's say, 2. 4 times 2 is 8, and what's my output is 7. Okay, so how do I get from 8 to 7? I go minus 1. Okay, so we found the explicit formula there. All right, let's take a look. here's a geometric one, 4, 12, 36, 108. Okay? So let me just kind of make a different one for you here. We've got 5, 15, 45, all right? So basically, to get this second term, I take A sub n equals, well, let's just go ahead and first, let's take a look at my sequence here. 5 to 15, the difference is 10. This difference is 30. So it's not linear. Okay, let's try to see if it's geometric. 15 divided by 5 equals 3. 15 divided by 5 is 3. 45 divided by 15 equals 3. So there's my common ratio. Okay, all right. So looking at, one second, guys. Okay, all right. So basically, what I can do when I work this formula, I say, well, if I have 5 and I times it by 3, I get 15. And if I have 15 times by 3, I get 45, and so on. So basically, my recursive formula is basically my nth term equals a to the n minus 1 times 3. Okay? I don't know if you can see that, okay? All right? Okay? All right? So here's a recursive formula, but it only works if I know the preceding term, okay? Now, let's try to get what we call the explicit formula, okay? So I've got this 5, 15, 45, okay? We know the common, let's go back to what we remember our geometric formula is A times R to the K minus 1 or the N minus 1. So my first term, I'm sorry, A sub 1 rather. So my first term would be what? 5, and my common ratio is going to be 3, okay? And I'm just going to put to the n minus 1. So A sub n equals, here's the explicit formula. I don't need the preceding term here. I've got A sub n, any term, as long as if I want the first term, second, third, or fourth, I've got this formula. This formula does not require the preceding term. I've got the first term, which we start off at 5, times the common ratio of 3. I plug in 1. 1 minus 0 is 0. 3 to the 0 is 1. And 1 times 5 is 5, my first term. I plug in 2. 3 to the 2 minus 1 is 3 to the first power times 5 is 15, and so on. So this is the explicit formula. Okay? So we just have a pretty easy day tomorrow. And we're just going to work a couple of these problems. I want you to develop the, let me see. Oops. I want you guys to develop the formula on some of these problems. Here's about 4 of them, and we got a few more, okay? And then we'll finish up Tuesday with some more problems that were on the, let me flip this around here, that were on the CBA so you understand. And then we're going to move on to logarithms and exponential problems, okay? That's all I have. I'm going to post this. Have a good day. See you tomorrow.